Bismillahirrahmanirrahim. Dear students, today we will cover very important lecture. You will learn today what are polar bonds, what are non-polar bonds, how polarity is important in some very specific or peculiar characteristics of organic compounds. How a compound becomes polar. I becomes polar and why compounds are non-polar. As described earlier in your previous lectures that due to electronegativity difference, poles are formed. In HCl, as chloro group is electronegative, so most of the time electron density resides towards chloro, and as a result H becomes partially positive. Now due to this electronegativity, polar compounds are formed. Polar compounds, I told you before that due to these poles, dipoles, partially positive and partially negative, or positive, H positive and Cl negative, these two or dipoles are formed, and these type of compounds, they have a property called dipole moment discussed earlier. Now today I have to tell you about hydrogen bonding. When hydrogen bond, when hydrogen is bonded to the most electronegative element, hydrogen bonding is observed. It is of two types. If hydrogen bonding is between uh, within a molecule, it is intermolecular, and when two molecules or three molecules other than same molecule are involved, then this is intramolecular, between two molecules. When hydrogen bonding is within the same molecule, it is intermolecular hydrogen bonding, and when it is uh, between two other molecules, it is intramolecular hydrogen bonding. And it is so important that it has influence not only on boiling, melting, viscosity and other properties of compounds. And this is all just if you have concept of polar, non-polar character, you can easily understand the importance of other concepts. Hydrogen bonding is so important that you know every cell is made up of protein, carbohydrate, nucleic acid, fats, lipids, water, mineral, vitamins, and proteins. The major component of any cell is protein. Protein has primary structure, secondary structure, tertiary structure, and quaternary and functional proteomics. So it is so important that protein is the structure of protein is due to hydrogen bonding. Protein of DNA, the helical structure, double strand, helix of DNA is due to hydrogen bonding, and when it is unzipped, messenger RNA or synthesis of proteins and transcription, translation, all these phenomena occur. So hydrogen bonding is much important. Although hydrogen bond is not a covalent bond, or it is not as strong as ionic bond or coordinate covalent bond, but still, although it is weak bond, but it is very important in all organic chemistry. So now these polar, non-polar, it is not, although it is very simple, but it is very important. And polarity or polar character is due to electronegativity of any atom in the molecule, like CH3Cl alkyl hal is an alkyl halide, and CH3 has delta positive character, and chloride has delta negative character. It has dipole moment. CH3Cl has dipole moment. CH2Cl2, CH3C CH3Cl is polar compound. CH2Cl2 is not polar compound. CHCl3 is polar compound. Now, in CHCl2, two chloro groups, two polar groups are present, but they are cancelling their effect. So there is no dipole moment, or net dipole moment is zero. So I hope you understand polar, non-polar, electronegativity, hydrogen bond, dipole moment, and how they influence on boiling point, melting point, viscosity, density of the compounds. Now, I have told you differences of polar and non-polar bonds. You know, polar bonds are covalent in character, while non-polar bonds are, they are also covalent bonds, but that non-polar bond is between those elements which have almost same electronegativity. When there is no difference of electronegativity between these two elements, it means they don't have any polar character in it. Now, in polar bonds, one of the element is electronegative, so the electron cloud is distorted. It is not normal. One element has negative, partially negative character, and the other, in contrast, other has some partially positive character. But in non-polar, there is no question of distortion in that bond, because both elements are of same extent electronegative. Third thing, as there is electronegativity difference, so on their poles they have charges, positive or negative. Partially positive, best way to explain, partially positive, partially negative. In non-polar there is no question of partially positive, partially negative. So when they have two poles, one positive, one negative, it means they should have dipole moment. But in non-polar compounds, they don't show any dipole moment, because no electronegativity difference, no distortion of electronic cloud, no charge buildup. So the last thing, that in non-polar bonds, van der Waal interactions are commonly seen between non-polar compounds, and in polar compounds hydrogen bonding occurs as there are charged partially positive or partially negative poles are present, so there is possibility of hydrogen bonding amongst in polar compounds. Now, what is hydrogen bond? It is Hydrogen bonding is due to dipole-dipole attraction between molecules. The most electronegative elements are nitrogen, oxygen, halogen, or any other electronegative atom. The strength of hydrogen bond ranges from 4 kilojoules to 50 kilojoules per mole, less than covalent coordinator ionic bond. So, due to the difference in electronegativity between hydrogen and other electronegative atoms like halogens, oxygen, nitrogen, this causes a highly polar covalent bond. So hydrogen bonding occurs due to this difference. Now there are two types of hydrogen bonding. One I told you, intramolecular, and another is intermolecular bonding. When it is between atoms of a molecule, so this is intramolecular hydrogen bonding. And when two different molecules are involved in hydrogen bonding, then this is intermolecular, and it is commonly observed in water. This is very common or simple example that one hydrogen in a water molecule is forming hydrogen bonding with two water molecules. Now, how it is working? Polar nature of the water molecule means each hydrogen atom experiences attraction to both the oxygen it is bound to and the non-hydrogen side of the oxygen atoms of other water molecules. I have drawn the structure how hydrogen bonding is formed between two water molecules. This is the region. Everything in the nature is not useless. Why this hydrogen bonding is important? That hydrogen bonding in water results in the crystal structure of ice, making it less dense than water, and snow floats on the on the water level, and due to this floating of snow and not making whole water ice is very essential for the life of aquatic animals in the sea, ocean, in the sea, river, ocean, lakes, ponds, etc. If all the river water, all the pond water becomes ice, it will be impossible for aquatic life in that water to survive. Now, in chloroform, one hydrogen and three chloro groups. So again, room for hydrogen bonding, and it occurs one molecule of carbon and another molecule of carbon. Ammonia, again nitrogen is electronegative, possibility of hydrogen bonding, and it is observed in methylamine. I have drawn the structure. Acetyl acetone between hydrogen bonding occurring between oxygen and hydrogen. DNA, as I have told you that the double helix shape of DNA is due to hydrogen bonding, and it unzips during replication, and it is very important in as genetical or inheritance of characteristics from one generation to another generation is due to DNA transfer. Nylon, very important polymer. Again, this polymer is formed by the repetition of units with the help of hydrogen bonds. Hydrofluoric acid, also for in formic acid we observe the phenomena of hydrogen bonding. Proteins, I told you that the foldings of proteins is due to hydrogen bonding. Not only nylon, other polymers, many various polymers are due to hydrogen bonding. uh, Cellulose, polyurethane, urea, uh, due to hydrogen bonding, the tensile strength and melting point is affected by hydrogen bonding. Other compounds like alcohols and acids, they also form hydrogen bonding. Now there are various properties of hydrogen bonding, but how they influence other properties like solubility. Lower alcohols are soluble in water, but as the alkyl chain increases, the solubility in water is minimized because hydrogen bonding is not taking place due to lengthy chain of alkyl part. Volatile. The volatility of compound is also influenced by hydrogen bonding. They will have higher boiling point than a higher boiling point, so it means it is less volatile. Viscosity and surface tension phenomena is also influenced by hydrogen bonding. Their flow becomes comparatively difficult. They will have higher viscosity. Viscosity, you know, is the resistance of layers when any liquid or fluid is poured. Okay, as discussed earlier, that ice floats on the water due to this phenomena. In the case of solid ice, the hydrogen bonding gives rise to a cage-like structure of water molecules, caging. It is known as caging. Caging. As a matter of fact, each water molecule is linked tetrahedral to four water molecules. The molecules are not as closely packed as they are in a liquid state. When ice melts, this case-like structure collapses and the molecules come closer to each other. Thus, for the same mass of water, the volume decreases and density increases. Therefore, ice has a lower density than water. Now, types, as told earlier, intramolecular hydrogen bonding and intermolecular hydrogen bonding. And I told you this is not as strong as covalent bond is, or other coordinate bonds, or ionic bonds. But even it is not as strong as other bonds, but it is very important and significant in understanding organic chemistry. I hope it will help you in understanding different concepts of chemistry.